started recording to your computer. So,
All set. That'll
okay.
come to me anyway. So
Okay, great. Okay, Jim, why don't you go ahead and start and I'll straighten out my screen issue.
Perfect. Sounds good. Well, first of all, I want to say thank you for letting me have the opportunity to talk. This is super cool. It's not a venue or a group of people that I've had the opportunity to talk to, at least in this way before. So I appreciate the opportunity. And my talk today, when Craig asked me to do this, I was thinking, what is it that I think would help that particular group, or what do I think would be beneficial? And I was reading about some topics at the time, and I thought I really think what I'd like to do is to talking about science. It's not something that's going to benefit just those instances where you're at the telescope or you're sharing your stuff, but I think that will benefit um, trust in science and people in general in a lot of ways. So I think it's a great opportunity. But yeah, welcome. My name is Jim Bader. I'm the director of the RMSE Strasenburgh Planetarium. And I'm here to talk to you about my day-to-day job, which is talking about science with people. So let's jump right into it. So I have a little line here. Astrophotography or sidewalk astronomy, we all love to share our favorite facts about the universe. Um, so whether and I think this applies to um, however you are interested in astronomy. So whether you're just taking photos of the sky, or you like to drag your scope out on the street corner, we all likely will be sharing our journey through amateur astronomy and astrophotography or whatever it is in some way or another. And my conversation is really just a big info dump of a load of information that I think will be helpful when you are doing the actual sharing portion of what you're looking at and what you're seeing in your telescope. So I was trying to find interesting images for each slide, just something to add to it, some accoutrement to each of these little chunks. And this image is so fascinating from a Popular Science in March of 1921. This is supposedly, according to the Popular Science article, somebody doing some sidewalk astronomy, in quotes, in New York City. So just for a moment, I want you to imagine the weight of that telescope and the mount that goes with it. That feels off the rails when I see this. So either way, it's a great example of what we're talking about. So many folks who find themselves excited about the pursuit of pointing a telescope, whether you carried this huge hunk of metal that's in this slide out or not, and you're trying to find a Messier object, or you're peering into the vast craters on the moon, or maybe you're gawking at the ringed jewel of the solar system. It's kind of inevitable that we want to share those views, the beauty that we see in it or experience in whatever way. What we notice though, and a lot of people probably can attest to this, is that when we see people share facts, um, those facts might be really obvious common misconceptions that are being blindly spread, or maybe they're close, but you're leaving out important points in that. And I have to say that I am guilty of doing some of these. The only benefit of using these in some cases is if you understand the what makes it incorrect, understanding the pitfalls of that. Well, it's mostly true, but technically, the classic physicist response to something you think is interesting. Yeah, that's true, but technically, in one way or another. So I think it's important that you understand that perspective of what is and what is not reality. And I think that's a foundation of astronomy or science communication in general. So that's what we'll get into. So let's just see a couple of important points I want to make, which is first of all, people like to hear simple truths, even if they aren't based in reality. It's something that you'll notice we want to have a quick answer, a simple one, a yes or a no to lots and lots of things. And this just doesn't always work, no matter how easy you want to make stuff. And science discovery is always changing things. So you don't always have that opportunity. And you have to make conscious decisions on what I want to say, that this is, you know, saying this in a definitive, absolute way, or is not, or maybe I want to make it a little more truthful, which can often be more obscure and complicated. So we'll get to examples as I move into this, but um, uh, what my approach to this is one that I probably read this somewhere, and it's probably a mess of a couple of different approaches that facts, especially in science, they're only true until they're not. And you could change that. You could say something that probably I'll do this repeatedly. I think Richard Feynman is somebody I use a lot of inspiration from, but facts aren't true. They're just not yet wrong. Because the more we learn, right, the more that stuff tends to change. So we're constantly pursuing new things and learning these new things. And as you collect more data, as we build more sophisticated instruments to collect more data and observe things in the universe, it changes the reality of what we understand, right? Constantly, we're doing this, and that's the hope, is that we can upset ourselves repeatedly, or find the patterns that will help us understand things a little bit better. All right, so let's talk about some examples of what I think is a great place to start. When you have the opportunity to show somebody something, like maybe, for instance, you're showing the moon in a telescope, and somebody asks you a question, whatever the question is, do you first give them the full and entire answer, or do you decide, no, I think what I'll do is give them a quick truth? It can be a little dangerous. So, a simple question. Every day in the planetarium, I will show people the moon in some way or another. I might zoom it in so they can see it up close. We might fly out to it. Maybe I'll leave it alone. But a question you get all the time, even from second and first graders, is how far away is the moon? That's a great question. And so I just can I ask you guys the answer? Will somebody be obnoxious for me and tell me how far away the moon is right now?
Quarter of a million miles.
A quarter of a million miles. That's a pretty good answer. So I could give two options in this case. A quarter of a million miles, like you said, or some less. I mean, I just chose a kind of a random number there, and I think that all of us know that neither of those answers is correct. It's not the case, because, well, we understand that as the moon goes around the Earth, it's not a circle. And as being an ellipse, that means that sometimes the moon is a little closer and sometimes it's a little farther away. And you get to make that decision on, do I tell them the whole truth, or do I tell them the answer that is mostly correct that they want to hear? And the reason that I'm giving this talk is to point out that, well, that response, there's never a single clear way that you should be doing this. But taking any opportunity you can to give people the window into the reality of how science works will give them trust. And maybe, just maybe, if you tell 100 people the reality of the way this works, maybe a handful of them will take that, and it will help build the trust and the way science actually works in life, which we'll talk about later, will absolutely affect them. So we can move on. I hope you guys see this picture and you're all feeling nervous. What could I be talking about with that photo here? Well, science is ever changing. Good examples. People throughout history were pretty convinced the Earth was flat, and we know that to not be the case today. But these questions, like how far away is the moon, this has been a question that we've been trying to answer for a long time. We've been calculating these answers for millennia, and in some cases, getting pretty close. But the more we learn and the better those calculations get, we start seeing clearer and clearer pictures. And that answer that technically changes pretty consistently. So the quick fact of roughly a quarter of a million or 240,000 or whatever you want to say, depending on the day, can often be like the best immediate response, right? You could even say something like, it depends on the day. And we don't want that to be too cynical or maybe sound condescending. So making a conscious decision to yourself to give an answer that makes a little more sense, because facts are not always definitive. Um, in science, when you ask that question, is it 250,000? Not today, but in 2 weeks, it will roughly be 250,000. But right now, when it's closer, you have an opportunity to tell them that and then drop a silly anecdote about something of, it's currently the supermoon, which we could get to. So that brings a question that is almost certainly a bastardization of a quote from Richard Feynman. Should you then teach them differential equations to ask about the distance to the moon? And the answer, I think we all know, is no. You definitely should not be doing that unless you are a differential equations professor and this is part of your job. So definitely not doing that. So my approach to this, I like to build my answers to things in a way that will make people curious. You're not telling them something that's false, and you are telling them an answer that, well, technically isn't true in that very moment, but giving them just enough of both of those pieces of the puzzle to want to ask a question. And whether that question is to themselves or that question is to you immediately afterward, or maybe that question is for friends and family or some specialist because you don't know the answer. Building that approach of hoping to get people, when you point your telescope at the moon or at Saturn or Jupiter or whatever, to critically think. And that sounds like a foreign thing to say, to have people critically think about it. But I've learned in the planetarium over the years that that's not what people want to do. It's a lot harder than you might imagine to get somebody to look at something like, let's say, Mars in the planetarium. If I ask a class of kids to look at Mars and tell me something about it, um, they will just repeatedly say Mars and say that it's a planet. They won't just look at it, and say a descriptive explanation for it, to critically think about what it is that they're looking at. And it takes a lot of effort to get children and people to start just describing it. It looks red. It's small. It's a point of light. It doesn't appear to be flickering or twinkling. And approaching that in a way that makes them really think, and dropping a hunk of information that will lead people into asking a question is important. So my approach when I'm learning new and interesting facts that I want to share with somebody is to ask myself the question, or a simple response of, how do I know that to be true? Whatever it is. How do I know how far away the moon is? Well, we've looked at this in a lot of ways for a long time. And then even in the future, with the Apollo missions, we took these fancy mirrors to the moon, which we set on the surface of the moon. And we now know that, well, we can actually hit those mirrors with a laser and know exactly, roughly at that moment, with the understanding of the medium between the space between the Earth and the moon, how far away the moon is at any given moment. We also learned that, well, the moon over time is moving farther away. And many of you may know this obnoxious and kind of gross anecdote that people like to say, which is it's getting farther and farther away from us at the same rate that your fingernails grow, which maybe it's just a pet peeve of mine, but that's pretty gross. You could also just say about an inch and a half every year. We learn these little facts slowly over time. But what I love to do, maybe more than giving an answer, is finding an opportunity to answer a question with "I don't know." Even if I know the answer to some extent, having that opportunity to feel beaten, where the kids or the public, your friends or family, can express that "I gotcha" moment. Like, I was waiting to catch you on something, and then you can take that time to explore the answer together. What else comes up? But using a quick anecdote about the history of that fact, for example, how we now know how far away the moon is today, since I'm going to continue using that for this example, can continue to make people see the whole process of how we got from the genuinely impressive calculations of people trying to find the distance to the moon, 1,800 years ago, to our very precise, with our fancy, sophisticated instruments that we use today. Either way, I think no matter what, you'll be hoping to keep your answers or your responses based in reality. So that means that you're avoiding at all costs talking too much. I have found that people who are excited about their particular hobby, like amateur astronomy, or whatever it is, we love to talk about our favorite thing in reality, and sometimes you talk a little more than you should. So learning how to pull that ripcord and get out of there and saying, I need to understand that a little bit better, can be safe. You don't want to lead people on a path of um, well, this science person, whether the guy down the road who maybe is an engineer or, maybe whatever, showed me this thing in a telescope and said that this was true. And I went home and found out that it wasn't true. Um, little seeds of distrust in science affect things way more than just you being excited about telling somebody in the neighborhood this cool thing that you can see in a telescope. Now, another example, and I love this actually. Mark hopefully knows exactly where I'm headed with this, as I kind of made this comment to him earlier today in the planetarium. And hopefully, seeing the picture, you guys know where I'm going with this. In science, as I mentioned, facts are only true until they're wrong. And I had a great opportunity to laugh about this afternoon with Mark, but also to myself after I got to find the new beautiful way to show this in the planetarium. So an example is, for instance, I'm in the planetarium just a couple of weeks ago, and I take people to Saturn. I zoom it in. We explore Saturn in lots of ways, but when we get there, I almost always will say that Saturn is the king of the moons. It's a phrase I like to use to describe the fact that Saturn has a ton of moons. And then I make a conscious decision to not say a specific number. I will say Saturn has a lot of moons. Now, I'm not trying to avoid the lack of understanding, but I'm aware that, and many of you know, the number of moons that Saturn has not stayed consistent, right? It's not steady throughout history. When you had Galileo Galilei, he looks at Saturn, he doesn't really understand. As a matter of fact, I think he writes down that he's pretty sure that there are two moons, but it's the rings because he doesn't really understand it to be rings, and it doesn't until
It's complicated, but due to my extenuating
uh-oh.
circumstances,
Um,
I will not face any charges.
got it, nailed it. Okay. Muted. Uh, so to continue back where I was about the moons of Saturn, I make a point to not say it, but also I do this because um, it is a weird amount of engineering a presentation so that you say the right things to make people ask questions, and it works like a charm every time. You can bet on it that somebody will immediately, after you said it has a lot of moons and then gave it a title, they want to know how many. So they raise their hand and they ask the question, how many moons does Saturn have? Well, can anybody tell me right now how many moons Saturn has? Mark, yeah, go. You know.
I can tell you how many we've counted.
Yeah, sure. That's probably exactly. You're crushing it. Exactly what I meant, which is how many is there? Well, we only know how many we've seen, which is
Right.
maybe problematic.
Well, at
But
U of R Family Day on Saturday, when I was asked that, I said I'm not sure how many it has, but it has more than it had 2 weeks ago
yeah.
when they reported all these new moons that were seen.
So that, I mean, like when this question came up a couple of weeks ago or whenever it was, I don't, it was earlier this month. Um, my response is is to make a joke of, well, the specific number has changed over time. And the last time I checked, it was a little less than 150 or 120 or whatever it's been over the years. And what I love about that is that I told them something that wasn't true. Um, this is according to NASA and realistically astronomers, but I did just double check it on the website before the talk to make sure that, yeah, NASA says this. Saturn now, according to, I think, March 12th, has officially an additional 128 moons that it didn't have before, which brings it to a grand total of 274 moons, which is off the rails. That feels like nonsense. And I think hopefully, and this is a tangent, hopefully astronomers start having a 2006 conversation, but instead of what is a planet, we talk about what is a moon, because the number 274 makes me turn off my brain. It's too big. That seems absurd. So if you want to see that absurd number of moons in the planetarium, you can just come on in. We'll show you an obnoxious number of lines that completely cloud Saturn out. Either way, so the good news that I think for me is that when the kids go home, regardless of whether I lied to them or not, because I didn't know, I had set them up for it as changing. And I made a point of saying, the process has not always been, not the process, but the number of moons has not always been the same because the process of science takes us through that journey of, well, we use a telescope, we check how many moons are there. I discovered this many moons. The next scientist comes in and does some research, checks on the moons that I have and says, yeah, we've seen this many moons. And with Saturn in particular, at least I have noticed that that number hasn't been consistent over the years. It goes up and it goes back down a little bit, and then it goes up, and that's frustrating for me. So partly why I will say, I don't know, a lot. Saturn has a lot of moons. Last time I checked, and now last time I checked, 274 feels ridiculous for me to say out loud, but either way. All right, so I just want to cap this chunk off over this portion of the talk just a little bit. Some expressions that I like to use instead of just dropping the hard facts, which I will reiterate, I think most people like a straightforward, simple fact. And you can give that, and I think that often if you just use a little verbiage to make your answer more correct or to cause them to ask an additional question, it can be safe. Some versions of stuff that I use is our current understanding. Somebody asks you, where did the moon come from? I think all of us know you can't really say, absolutely, I know the answer to that question, but we do have a very good current understanding based on real data in real life. There's a good chance that the Earth got hit by a huge object early on in the solar system formation, and that slowly coalesced into the moon that we have today. There's a lot of steps in between there. I'm not, I'm kind of jumping over a lot of stuff, but that is a current understanding. Another way to not tell the incorrect thing is to say that astronomers have suggested. So why are there rings on Saturn and where did they come from? Once again, we weren't here to see them form, but we can absolutely collect data, tons of it, and then use that data to create models. And from those models, get these suggestions. So astronomers have suggested that, for instance, in the case of Saturn, maybe one of the suggestions is that a moon was destroyed. Maybe a comet came by and pushed the moon too close. Maybe it interacted with another moon. But one of those big suggestions is that a moon was destroyed by tidal forces. But there's lots of ideas as to where, because we don't fully understand. And how old are they? How long will they last? Why is it mostly just water ice? Now, my favorite personal answer is I don't know. As you guys have seen, I love to get to say I don't know to anybody, whether I'm sitting at a telescope or not. But for me, getting the opportunity to tell somebody you don't know something shows, first of all, that there is still so much to learn, and not just you in that case, but astronomy specifically, not just, in all the sciences in reality, the scientists and humanity, we don't know. We don't know most things in earnest, right? So getting to say, I don't know, and that scientists are still in agreement or still in disagreement, um, is a great way that applies to a lot of things that seem obvious, right? Not as astronomy related, but um, a kid asking, how did the dinosaurs die? That's a question you get in the planetarium more than you might imagine. But the answer is we don't really know. There's a lot of good, explanations, just like the rings, but a lot of scientists are still in disagreement. So, what is dark matter? We don't know, and most scientists are in disagreement on that. Dark energy, or another fun one that I was reading about recently, which is spiral arms of galaxies. Why? Um, we don't know. That seems so fun, but I can't say that enough. Yeah, getting the opportunity to say, I don't know, and sharing with someone just that moment of the process of science and why we don't know, or why it is just our current understanding at any opportunity you can, but doing so in little snippets. So I want to also give an example of a bad decision that I do all the time. And this image I had ChatGPT make for me. In case you're curious, I told it to put Saturn in a bathtub. So I hope you guys know where I'm going with this one. Um, Saturn, this is a fact. It has relatively low density. When you look at planets, it's not a rocky planet. It doesn't have the density of that. It's pretty low density. So a common anecdote that you hear many people say, not just in planetariums, but all over the place, they would say, if you had a bathtub big enough, Saturn would float. Have you guys heard this? And I hope you know that it is just not true. It's not true. But let me add the caveats, which is just for a moment, imagine you actually had a bathtub big enough to hold Saturn. The laws of physics that you're defying to create a bathtub that big is problematic. Secondly, Saturn is not like a hunk of wood. It's not a solid thing. It's a gaseous planet. So that's problematic. What about the rings, right? There's a lot of these silly, well, technicallys that get in the way of some simple answer like yeah, if you had a bathtub big enough, Saturn would float. Even though I absolutely say this to kids, I don't know, at least once a week. And with small enough kids, you'll certainly hear me be, dropping a metaphor of a rubber ducky in Saturn for the sake of it to get the point across. But this is really fun. I would say a lesson in reality, but also more of hitting that home. If you haven't read this article in Wired called No, Saturn Wouldn't Float in Water, I can't recommend it enough. I'll see if I can copy it and put it in chat at some point. That might be a little obnoxious. See if I can try. I'm going to do it. Can't recommend that article enough. It is a blast of somebody who did actual work to explain why that's the case. But no, it definitely wouldn't. Okay, so I kind of blasted through a lot of this talk, and let's get to, I think, the meaning of it all. That I would have to say. Why is it important that you're careful when you talk about science, especially when it's just a particular hobby that you have? Is it affects things in lots of other places. If we're going out and dropping our quick tidbits, and this is causing just a little bit of mistrust. Oh, well, the planetarium director, he said very confidently that Saturn only had this many moons, and I went home and he was wrong. So this person that I'm immediately correlating with the idea of science said something that turned out not to be true. And that is just one little chink and the armor that would, hopefully keep people safe and healthy, literally. A good example. What if we had a global pandemic? Not that this would really happen, this is all theoretical, of course. And many doctors in the world said to you, we don't understand it. You should wear gloves and wear masks and be terrified of it. So you are, and you do that. And you guys know how this might go. Maybe people start spraying their groceries with Lysol or something, wild like that. And then the doctors tell you, you know what? Actually, you don't need gloves. And you're wondering, well, that's weird. They didn't explain it enough. They just said you don't need gloves, but we did need gloves. And then somebody says you actually need a mask, but then they say you do need a mask. And because they're not explaining the science, because that is being dropped out when people are telling the facts of, well, science is ongoing, right? It's a quote that I'm sure I didn't make up, that somebody probably said to me, and I just regurgitated it because it feels nice and because I think it does a great job of explaining this, is that science is not a collection of facts. It's more like a toolbox, a way of learning about the world. But when you always hear science just reiterated as a collection of facts, the science says you should wear a mask, and then the science says you shouldn't wear a mask, and then the science says you should wear a mask. So I can't believe in science because it's flip-flopping just like a politician. I think that you should be careful because misinformation, it happens constantly in small little chunks. And if we're being consistent as stewards of something that is a hobby to us when we're talking about it, you're doing things that actually, albeit wildly separated, could save lives, to mitigate some of the distrust in science, because that can be deadly. And this is not something that I would ever fault somebody for, because stuff like conspiracy theories and other stuff, this is designed to make you want to read it. I read the conspiracy theory stuff. It's wild, and I have a great time doing it. But the problem is that, people fall for it and they bite in because of, throughout their life, little chunks of mistrust in science, or because somebody wasn't consistently giving them a way to critically think about the process of science, that it isn't just an open book and I read the facts. I can open my favorite copy of what I like to take for stargazing with a telescope, which is Night Watch, and find a fact in there and reiterate it. It's important that I understand that fact. And I asked myself the question, how do we know that to be true? Can I learn it? I don't necessarily need to learn all the maths necessary to get to that answer, but that I at least took a few moments to find out the process it took to get to the answer that we have today, and why it's true. How do we know that it to be true? You can trust scientists, and you just have to do it carefully. I'm not saying that people need to go out and find ways and classes to learn how to read scientific papers. They're full of jargon and obnoxiousness, but you can definitely brush through them. Find sources. I probably don't know if I would recommend using AI to ask those questions. How do we know? For those questions, but maybe they're learning. My personal choice is, if I can find an article from a website or a group that I know, I feel confident and trusting, places like Sky and Telescope, or Wikipedia, which is, like me growing up, Wikipedia was an absolute no, but there are sources in Wikipedia and they will take you to a scientific journal, on a trusting, reputable website to let you really get the answers to that. Or reach out to somebody else who has the answer. Regardless, the whole takeaway that I want you to have from this talk is that if you're going to share, and I think you all should share, your pictures that you're taking, your moments in front of a telescope, your time in the backyard pointing at stuff in the sky, to think for just a moment, to be careful about the way you say your favorite fact about your favorite object in the stars, just to hopefully give somebody a correct view or insight into how science really works, which is, it is not necessarily a super rigid thing. It is a process that we're using to learn about the universe, that we have been using for quite a long time, and will continue changing our views and perspective on things because data suggests that it makes sense to do so. So hopefully, the data and our understanding makes sense to reduce the number of moons of Saturn from 274 to something a little bit more reasonable. And we add a new term like it is a dwarf moon, maybe. That could work. Anyway, that's the bulk of my talk. It went quite quickly, but I don't want to harken on if it's not necessary. Really, I think if anybody has questions or they want to bring up a gaping hole in my conversation, I'd be more than happy to discuss that.
I don't have a gaping hole, but I really love the outreach stuff that I get to do, especially the stuff that has kids coming by. Like I mentioned on Saturday, Dave Bishop and I were at U of R with all middle school and younger kids coming by, and we had globes of three planets, or our moon and three planets, and um, just listening to the questions they were asking. They're at that age, they're a lot more comfortable than their parents are with being told I don't know. Um,
I agree with that. Adults sometimes they expect you to know and they want you to know, and that's the problem of like people just want simple fact. They want you to give them an answer and to turn around and walk away. And I think that's tough and it feels bad that it's just not the case so much of the time. But I think that maybe is why I get to love my job so much, working with school kids, that age group from like I don't know. Mark's in here, Steve's in here. You guys have done this, but somewhere between third and fifth grade, they have no issues just exploring the reality with you for just a moment. And that, oh, that is really wonderful.
Jim, it's Steve. Nice to see you again. Great talk. And an observation of mine, see if you agree with this, is that kids in that age group you're talking about are great because they'll ask unfettered but interesting questions that make me think. But they're at a developmental phase where they don't quite understand approximation and estimation. So, for example, I was doing an activity where scale model of solar system orbits. Cutting to the chase, their job was to make a mark that was about 4/10 of a foot. They all had 12-inch foot rulers, and it came out that they had to make a mark that was 4/10 of a foot. They hadn't yet learned that arithmetic operation of multiplying 12 inches by 4/10. So some of them were doing 4 inches, and some of them just stopped dead and asked, how do I do that? I said, well, 4/10. Now that's a little, is that more than a half or less than a half? It's less than a half. Is it a lot less than a half? No, it's almost a half. Okay, do something that's almost half a foot. Well, that would be like 4 inches, should it be? They're looking for, it's like the brain at that age wants a definite answer. And it's not till like late junior high school when they can understand there are situations where you work with an estimate that's good enough for the current situation. And that takes some judgment and experience too.
I definitely agree with you that it is it's tough to make the decision. Do I give them the short answer? And so I think I haven't had to get somebody to get 4/10 of a foot. That even at first, when you first mentioned that, I was like, whoa, that would take me a moment to just sit back and think for a second. I think I would arrive at the answer, but regardless,
Yeah.
Yeah, you have to decide. So typically, I just like to give them the short answer and then give them a description or, preface it real quickly. Well, these things are not always this way, but in this particular case, the answer is X.
While I had the floor, just one other thing to tie into your very last point about, I agree, public understanding and public explanations of the pandemic or a disaster. Climate has been a disaster. But the one institution people still trust is the local museum, the local planetarium. They trust museums more than, there's a Pew survey about this, trust museums more than almost any other institution. So a local person who they can talk to and converse with until they reach the level of understanding they want for today is just crucial. And while I was in the job, this was a thing I was constantly harping on with the vendors and the consultants is what matters is the local reputation of the institution.
I definitely think that's important, especially for Mark as he's doing that conversation at a local museum, and Don Chamberlain and a few of the other people. Yeah, I like that. And I'm going to be reaching out to you about something, Steve. You just brought up. We'll do that outside of the main group.
If I can make a comment, when I do a star show at the end, especially of a Sky Tonight show, I'll ask people to come up if they have any questions. That's a real loaded question to ask because I get all kinds of questions, and then when I get some kid that's 9 years old comes up and wants to know what dark matter is, I don't have time to give him that answer. And so it's a very short conversation, basically saying it kind of fills in for something we don't know. Here's what we see happen, and we use dark matter to explain that there's something missing here, and so that's why we call it dark matter, and that's why we call it, or that's why we call it dark energy when we refer to the what's holding galaxies together. So it's really interesting how to do that in a very very short period of time because you don't have time to give a any kind of a thorough answer.
And in a lot of those cases, I mean, I don't know the answer, right?
Oh,
And I think that most astronomers would agree they probably don't know the answer, and that's the point. So, yeah, I don't know. For me, and I know I'm not everybody, there's something so like magical about the darkness of not knowing. I like that we don't know these things. It feels comforting, uh the fact that we don't know all of these things, I feel like a normal person, that there isn't somebody out there who just does know all of this stuff. So yeah, I don't know.
I'll just pop in here and just say that a lot of the cognitive studies in people is has found have found that people generally fall into two different categories in terms of processing uncertainty. There are those people who can only deal with yes and no, black and white. And then there are those people who have a much more nuanced way, nuanced processing and are able to accept a lot more uncertainty. And that's why you see a lot of differences in terms of people's ability to understand and accept things like science changing. Those people who see black and white, there actually have been fMRIs done on this, and Craig, you know a lot more about this than I do, probably, but on the different processing that people are do in terms of their ability to deal with uncertainty. So that's really important for those of us who understand science and wonder why there are a lot of people who reject it. Those of us who understand science know it will change as our knowledge about a particular area becomes deeper and richer. But those people who need a yes or no answer, they can't understand that. So it's pretty fascinating in terms of just the cognitive processing.
That being stuck in yes or no, what is that has an interesting term, maybe false dichotomy or something like that is what maybe I'm grasping at straws there, but yeah, that is really wild. I mean, I think I always just, for better or worse, hope that people can have the opportunity to learn and explore these things in a way that I can. And I don't think I'm a particularly smart person. I think I'm a particularly hard-headed person. And I just won't stop until I get the understanding that I feel like I need. And I hope that for everybody else too.
As a physician, helping people understand and deal with the uncertainty of medicine, at least, was the biggest part of the job. Because the stakes were in a lot of ways higher for them. They really wanted to know, how long or how bad is this or um, and one of the things I learned to do was to acknowledge the uncertainty, but say I am certain about how to go about reducing it. Like my training has helped me figure out what to do when I'm not sure about something and I know how to approach it. So I don't look like I'm at sea, but I still get to acknowledge the uncertainty. And in this situation, I think it gives you the chance to segue from the uncertainty of what we don't know about the universe um, to this is how science tries to figure it out. There is an orderly process for figuring this out, and that's what science is all about. And in fact, it's the only way we have, it's the only method we have of trying to figure it out. And that gives you a chance to talk about science a little bit.
I love that. That's really that sounds perfect from.
Other questions or thoughts?
I definitely was trying to be careful about how long I talked. I have a tendency to drag on, so maybe I should have been a little less careful throughout that.
Now, I don't think there's we don't have a time frame that you have to go to, or it was a very thought-provoking talk. And I'm going to use some of what you thought about next time I'm at an outreach event.
Yeah.
Um, definitely. Um, and maybe not about some things, maybe not trying to sound so certain or being, I mean, as a very, 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 very amateur astronomer, um, I get anxious when I'm uncertain, but you've helped me feel a little less anxious about it and maybe more proud of it. Mark, you were going to say something?
No, I was going to
Okay.
say something.
Oh, Dave.
From I really liked your talk. Just I'm putting that out there. I really enjoyed it. I was smiling, nodding my head. I got it, and I relate a lot with kids. I do a lot with scouts and younger scouts a lot too. And I just started doing junior achievement. Oh my gosh, you got to do that. Um, most of my questions that I get asked are from adults. And one thing that I have found myself getting better and better at is trying to understand why they're asking the question to begin with. Because I get a ton of questions about technology. It's my job. It's what I do. I fix things that other people haven't been able to fix. And I have to pause for just a second and ask myself why they're asking the question because it that helps a great deal in how I approach it because technology is the same as science really because there are inexact answers and it depends. It depends on so many variables about situation and what you want to accomplish and so forth. So I really I love I resonated the entire time with what you're talking about with the inexactness of things. I have found myself getting better and better at trying to think, well, why are they asking? And sometimes I just ask them, what is your concern? Where are you trying to go? And that has been helpful. So thank you for doing this. And thank you, Craig, for sending me the link.
Thank you. That was
You're
really
welcome.
kind. I appreciate that.
Yeah, the question behind the question. Um, Again, in the medical context, if you could understand why people were asking the question, they feel really heard. More so than just answering the question, actually. If you're listening hard enough to get at the question underneath their question, and address that, they feel like you've really heard them.
I mean, on that note, like the idea of asking why they're asking the question, I think I find myself, and this is just something that I have learned in the process of giving these public talks to people about stuff, astronomy, whether in the planetarium or at an observatory or wherever, is that I have discovered that you could, in a non-malicious way, engineer the conversation so that you're offering those chances for people to ask the question. And you just give a talk and you realize every single time I say this thing, they always ask that question. And you're just breadcrumbing them along to the real discovery that they find from beginning to end. And that you have repeatedly, I get the opportunity to watch people go from I don't understand at the beginning to you gave them all the breadcrumbs and now you see that light just pop off in their head. And you can do that in little chunks rather than Dave, you're saying, which makes sense in your job, that you have to be like, wait, why are you arriving at this point? And in my case, I'm often setting the table and putting the pattern right in front of them. So that's a really interesting perspective on the same problem.
How
Other
often,
questions? Oh,
yeah, how often do you use Chat GPT to generate images like that Saturn one?
It does just a few times. That was the first try too. Most of the time, it's in some joke where somebody at work asks if this exists, and then me and the person who's in charge of technology at the museum will just continue to spend 5 or so minutes trying to come up with the most uh, realistic or ridiculous image version of it. I just typed it into ChatGPT one time. I said Saturn floating in a bathtub, and I can try to share it again, but bubbles. It was perfect. Exactly. A rubber duckies on the floor. It was everything that I could have hoped.
Excellent talk.
I like what you said about, paying attention to the source of the information that you're getting. Jim, that was really good. The other thing I've learned is like with YouTube is not only looking at the source, but looking at when the information you're viewing was posted. Because looking at a 10-year-old YouTube video could be just as bad as looking at something from a worthless source, because everything may have changed in the past 10 years.
Yeah.
And YouTube recently has hidden the upload year. You have to get you have to use a special add-on to find out what year the YouTube video you've looked at was posted. Because I try to in my talks I try to cite the year of the reference. And I had to figure that out how to do that with YouTube, because they don't make that part of the labeling of the video. And things are changing so fast that only a couple years can render something useless.
I have a tip for you, Craig. When you're doing a search and you look at the list on the right, they always have the age. But when you're looking at an individual YouTube video, it's not available.
Right,
So
right.
look at the gallery on the right to see the age of it.
Yeah.
But yeah, I hate that they don't say right up, right underneath the thing what the age is.
Other questions, comments?
Nice
Well,
talk.
Jim, thank you. Oh, Mark?
I was just gonna say, nice talk, Jim.
Yeah. Thank
Thank
you
you
very
so much.
much. That was a very thought-provoking, helpful talk, Jim. Thank you a million.
Yeah, absolutely. It was a really fun opportunity, and hopefully we'll do it again sometime.
Yes, absolutely. Just let me know when.
For anybody listening, I'll upload this to our YouTube page. There's all kinds of videos on there, like these astronomy forums, and then talks from our meetings are there. There's some old stuff, old meeting talks that are there as well. So that's Rochester's. It's astronomy section, Rochester Academy of Science YouTube page. You'll find it going to YouTube.
And Jim, I'll look up that reference, the references, and send that to you so you have that information.
Yeah, that's great. Just adding, I mean, bolster, that's more of that underlying reasoning for, well, I guess I didn't understand that. That is a studied thing that people struggle to understand the difference, some people, between yes and no answers, and other people can fully grasp the idea of a less
A less certain world.
yeah.
And that's actually very recent research. So I'll look it up and I'll send it to you.
That's awesome. Thank you. I appreciate
Thanks,
that.
Sally. All right. Well, good night, everybody, and thank you for attending. Next month will be the rescheduled talk about the sun and its effects on the earth, and I'll be giving that on the fourth Wednesday of next month. Hope to see you all then.
Good night, everybody. Have
Good
a
night,
good
all.
one.
Everyone.
Thank you.
Thank you.